Hello again. Today we're going to solve a equation, logarithm equation. This it's not an easy question because you involve with the cubic functions, cubic equations. So we need a long division. So I'm going to show you how to use a long division to solve. Before I do that, please remember to subscribe the channel so that you do not miss the latest updates. So the channel has now increased to more than 100 episodes, videos for you to watch. So if you subscribe, so you'll get a playlist, so you don't have to search individually. So you got more than 100 videos to watch. So just take this benefit to subscribe channel. Doesn't cost you anything. Just click the bell. Thank you. All right, let's solve this log equation. So we got a equation listed here. So I want to find out what x is. All right, so let's do the first one. I'm going to simplify the log. So first things, I'm going to use log law to bring 2 to the front. The reason I want to make the front number is 1. So I want to clear any number in the front. So why we need to put a 1 in the front? So because I can merge 2 logs become 1. So we got a log 3 as a base. So the x become x times by that become, so addition become product. On the right hand side too, I'm going to write down to a log 3 base and 3 to the power of 2. So that means there'll be, so we take it a log sign off. So we get a cubic function. So I'm going to expanding the brackets. So we got a cubic function listed here. So I'm going to try, because the cubic function, we don't have a formula. I'm going to try by error. So try error. So we just try, we call fx equal to this equation function. So we try f1 first to see if it's equal to 0. So we substitute 1 into the function, we'll get a 0. So therefore, the x minus 1 is 1 factor or root. So then fx become x minus 1 times by qx. So therefore, qx is fx divided by x minus 1. So we call quotient rule. So quotient, we can use a long division to solve for qx. So how do I do that? Can you see I put all the coefficients in the long division sign. 1, negative 8, all the coefficients, 16, negative 9, and the divisor, which is denominator, is x plus minus 1 become 1 minus 1. So what I'll do is first we match up the second one. So this is the x to the power of 2. So 1, why is 1? Because this is 1 and this is 1. So we need a 1 divided 1 is 1. So 1 times by 1 is 1. 1 times by negative 1 is negative 1. Then you subtract. So remember negative 8. Subtract negative 1 become negative 7. Then you move 16 down. So then we're going to use this number divided by 1 is negative 7. So negative 7 times by 1 is a negative 7. Then you negative 1 times by negative 7 become positive 7. So then 16 take 7 is 9. So then bring negative 9 down. So you times by 9. So 9 minus 1 is 0. So that means the remainder. So this is the remainder is 0. So therefore my quotient is qx, which is x to the power of 2, which is 1. So because he is 1, negative 7 times by x plus 9. So that's it. So therefore my fx becomes x minus 1 times by x squared minus 7x plus 9. So now we need to solve for x. So first, x equal to 1 doesn't apply. Why? Because if you look at the equation of the log function we call log x minus 4, in this case, x must be greater than 4, cannot be equal either. So therefore, the first x equal to 1 doesn't apply. So we have to exclude that. So next one, I'm going to use the quotient to solve the equation, quadratic equation. So what I'll do is I'm going to use a perfect square. All right, make a perfect square. You can use a quadratic formula, but I'm just using the perfect square. That's fine. We got some answer. So therefore, I've got a x, 2 x's, or you can use x equal to, remember, we call negative b plus minus b squared minus 4ac divided by 2a. You got same answer. Now, we've got two answers. One is a positive, one is a minus. Which one I choose? I choose this one because I need the x greater than 4. So the only answers is this one. That one is less than 4. So therefore, final answer is x equal to 7 plus square root 13 divided by 2. That's it. This will solve the log and the quadratic equations using long division. Thanks for watching. Don't forget to give us the thumbs up, and I'll see you next time. Bye-bye.